Welcome inside Japan's Kumamoto factory, and where Honda built the legendary Gold Wing, one of the most iconic touring motorcycles ever made. Right now you are watching the crankshaft and pistons being fitted into one half of the engine block, followed by the bearings and caps, more than 20 years ago. Honda Gold Wing was, and still is, one of Japan's most famous motorcycles, and it became an American-built icon for nearly 30 years. A U-shaped tool holds the pistons upright and keeps them perfectly positioned during assembly. Another tool compresses the piston rings, allowing the pistons to slide smoothly into the second half of the engine block without damaging the rings. A gasket is then carefully placed on top of the engine block to create a proper seal before the cylinder head is lowered into position. Finally, the camshaft is installed inside the cylinder head, completing another important stage of the engine assembly. Before the engine is installed in the motorcycle, it undergoes a thorough test to make sure everything is working properly. While engines were being assembled in one part of the factory, Honda motorcycle frames were being welded in another. Only on the main assembly line were all the pieces finally brought together. The 102-kilogram engine is then lowered onto a cradle, moving along a conveyor, and the frame is mounted around it. The rear wheel assembly is fitted first, followed by the front wheel, bringing the motorcycle closer to its finished form. The handlebars are then installed using torque-controlled tools to ensure every fastener is tightened to the correct specification. The brake assemblies are carefully mounted and secured as well. The motorcycles slowly move through the production hall as more and more components are added to the frame. The entire process resembles one giant puzzle, with each piece carefully fitting into place. This entire instrument cluster is mounted behind the front cowl. The cowl is then carefully lowered into position and securely bolted to the motorcycle's frame. With the major components in place, the exhaust system and remaining parts are installed, completing the final stages of assembly. But the motorcycle is not ready to leave the factory just yet. Each finished Gold Wing is taken to a dynamometer, where technicians measure its mechanical power and make sure the engine and drivetrain perform as expected. The motorcycle is also put through a series of functional tests. Technicians check its speed, braking system, horn, navigation system, cruise control, and other essential functions to ensure everything works exactly as it should. Every Gold Wing must pass this final inspection before it can leave the factory. Once it meets Honda's requirements, the finished motorcycle is ready to begin its journey from the factory floor to the open road. Gold Wing became an American touring icon without being an American brand. Honda realized that American riders were essentially telling them what the Gold Wing should become. Owners were adding fairings, luggage, and touring equipment themselves. Honda responded by turning the Gold Wing into a purpose-built luxury tourer. This archival video was filmed inside the Harley-Davidson factory during the company's most controversial period. In 1970, this factory built 40,000 motorcycles. Less than a decade later, in 1979, AMF pushed production to over 80,000 bikes inside these walls. This is where Harley-Davidson bikes were built from 1969 to 1981, during the years when the company was owned by American Machine and Foundry, AMF. To put that into perspective, Harley-Davidson produced only just over 120,000 motorcycles worldwide last year. During the 1970s, Harley-Davidson was facing serious financial challenges. Japanese manufacturers were producing motorcycles that were cheaper, more reliable, and easier to maintain. Harley needed major investment to survive and remain competitive. Right now, you are watching how the wheels and fenders are being moved to the beginning of the main assembly line using a conveyor belt. However, many enthusiasts also point out that the later AMF years brought important engineering improvements and investments that helped lay the foundation for Harley-Davidson's eventual recovery. Although the main final assembly operations moved to York, Pennsylvania, Harley-Davidson's Milwaukee facilities remained the company's beating heart. As you can see for yourselves, during this period the company moved from a relatively traditional craft-style factory system toward a more industrial mass production process. Milwaukee continued to produce the company's engines, transmissions, and other powertrain components, while also remaining a center for engineering work. As you can see, building a Harley-Davidson bike in the 1970s required far more manual labor. These engines and transmissions were then shipped to York, Pennsylvania, where the final motorcycle assembly took place. The difference is striking. The company employed around 6,000 people back then, roughly the same number as today, yet modern production has more than doubled compared to that era. After the final inspection, these factory workers prepared the bikes for transport from the factory to Harley-Davidson dealers across the United States and overseas. This was a turning point for Harley-Davidson, a shift from a craft-based builder to a mass production manufacturer. It brought ambition, innovation, and major challenges. As you can see from the archival footage, back in the 1970s, Harley-Davidson had a much more rebellious, countercultural, outlaw, and working-class identity than it does today. The AMF era was actually when the Harley myth was being created. Today, the Harley-Davidson image is more often associated with lifestyle, heritage, chrome, touring, freedom, and community. A Harley in 1975 represented independence, an escape from ordinary life, American identity, and individuality. It was not just a means of transportation. The 1970s saw a huge growth in motorcycle rallies, local riding clubs, custom builders, bike shows, and swap meets. While a Honda or Yamaha was often seen as simply a machine, a Harley was seen as a reflection of the rider's personality. People were not just buying bikes, they were joining a community and becoming part of a larger motorcycle culture. Mainstream riders built their own communities. Harley owners groups, local clubs, and touring groups focused on customization, long rides, and shared passion for the brand. The 1970s saw the rise of one-percenter outlaw clubs, known for their strict hierarchy, loyalty, and rebellious image. In the 1970s, Harley-Davidson culture was all about leather, denim, the rumble of a shovelhead. Every Harley-Davidson on America's roads is assembled right here in these US manufacturing plants. Right now, you're watching the first stage of the manufacturing process, the stamping of fenders, fuel tanks, and other body panels at Harley-Davidson's main factory in York. Some components are sourced from around the world, including China, but the engines and drivetrains are built in Milwaukee, Wisconsin, while the frames are assembled in York, Pennsylvania. Harley-Davidson combines advanced CNC machining and robotics with old-school hand assembly. Last year, around 170,000 motorcycles were sold worldwide, with roughly 100,000 of them in the United States. From Milwaukee to York, every Harley-Davidson sold in America carries the mark of US manufacturing. Around 70% of the parts that make up each motorcycle are produced right here in the United States. By comparison, Honda sells more than 17 million motorcycles every year. This puts Harley-Davidson's numbers into perspective and shows just how exclusive owning a Harley really is. The welded parts are now moved to the paint shop, where each component is hung on a conveyor system and slowly moves through the entire painting process. The frame is now being welded. The motorcycle's main frame is assembled using programmed robotic welding arms, while skilled workers handle more complex areas and weld any irregular sections by hand. The painting process is largely automated. Workers at this station focus on monitoring the system, inspecting the results, and maintaining the paint line to keep production running smoothly. At this stage, human craftsmanship takes over. Workers inspect the finish, apply the decals, and carefully polish each part before it moves to the next step of production. This production line is also highly automated. Workers here program the robotic systems and monitor the powder coating process through computer-controlled screens to ensure everything runs smoothly. The painting process consists of several layers. After applying an anti-corrosion treatment, the parts receive a primer coating, followed by the final paint finish, graphics, and decal application. This iconic motorcycle manufacturer currently employs around 5,700 people. Many of them work directly on the main assembly line, bringing each Harley-Davidson motorcycle together step by step. Despite the high level of automation used in many stages of production, Harley-Davidson still relies on thousands of skilled workers to build its motorcycles. In Harley-Davidson production, powder coating is used extensively on components such as engine parts and frames. This process provides several advantages: increased durability, resistance to corrosion and heat, and a smooth, high-quality finish. You are now watching the yellow and orange robotic arms handling the cylinder heads. These factory robots are expensive to install, but they deliver non-stop speed, precision, and consistency on the assembly line. In Harley-Davidson's V-twin engines, such as the Milwaukee 8, each cylinder has its own cylinder head. These heads are designed for air cooling and efficient heat dissipation, which is why they feature Harley's iconic cooling fins. Workers within this Harley-Davidson factory are trained for one specific activity within the manufacturing process. And this is what the cylinder assembly process looks like. Unlike fully automated operations, this step is performed by a skilled technician who carefully combines multiple engine components into one assembly. The American flag above the factory floor and the patriotic details throughout the facility highlight Harley-Davidson's strong connection to its American heritage. Hundreds of finished Harley-Davidson engines are stored in this central warehouse. Each engine is assigned a unique number and matched to the specific motorcycle model and configuration it will power. Located near Milwaukee, the Menomonee Falls plant produces Harley-Davidson's engines and transmissions, including the Milwaukee 8. The facility handles casting, machining, and precision powertrain assembly, with around 600 employees working here. This is the start of the main assembly line, where the frame, engine, and hundreds of other components come together piece by piece. Like a giant puzzle, every step moves the motorcycle closer to completion. This is where most York factory employees work. The Nightster and Nightster Special, followed with the smaller Revolution Max 975T engine, are offering a more affordable way into Harley-Davidson's modern lineup. This is the engine assembly of the Harley-Davidson Sportster S, completely redesigned in 2021. It introduced the new Revolution Max platform. Every step of the assembly process is precisely planned to keep production moving efficiently while ensuring every motorcycle is built to Harley-Davidson's exacting standards. The Revolution Max is a stressed member engine, meaning it serves as part of the motorcycle's frame. This design reduces weight while increasing chassis rigidity. What you're watching now is the installation of the Revolution Max 1250T stressed member engine into a Harley-Davidson Sportster S. Each workstation is staffed by a team of skilled workers, with a supervisor responsible for overseeing the entire operation and ensuring quality standards are maintained. What makes Harley-Davidson truly unique is the legendary legacy built over more than a century of motorcycle production. The Tomahawk factory in Wisconsin produces a wide range of composite components, including fairings, saddlebags, windshields, and other exterior parts. The company was founded in 1903 in Milwaukee, Wisconsin, by childhood friends William S. Harley and Arthur Davidson. The facility specializes in injection molding and painting non-metallic motorcycle components. Harley-Davidson combines modern manufacturing technology, such as CNC machining and robotics, with traditional hands-on assembly craftsmanship. Like in any manufacturing operation, pay depends on the role, experience, and years of service. Long-time employees with specialized skills typically earn more. Behind every Harley-Davidson motorcycle are thousands of hours of skilled labor. Factory assembly workers are typically paid between $20 and $30 per hour for their role in bringing these iconic machines to life. This machine measures the engine's torque and rotational speed, allowing engineers to calculate its power output, usually displayed in kilowatts or horsepower. You are now watching engine performance testing on a dynamometer, also known as a dyno. They are carefully packaged in protective crates and transported by truck across the United States. After final testing and finishing touches, the motorcycles are ready for shipment to dealerships and customers around the world. At the York, Pennsylvania factory, touring and trike models come together using advanced robotics, precision engineering, and even in-house chrome plating, blending modern manufacturing with Harley's iconic custom style. The Milwaukee 8 is the beating heart of modern Harley-Davidson, a powerful V-twin engine built entirely in America. Harley-Davidson is one of the most recognizable American brands in the world. For many riders, owning a Harley is more than owning a motorcycle. It is owning a piece of American history. Additional sub-assemblies and parts come from suppliers around the world. Around the factory floor, motorcycles are transported by AGVs, yellow automated guided vehicles that move parts and bikes efficiently between workstations. America's two legendary motorcycle manufacturers, Harley-Davidson and Indian Motorcycle, are among the few brands that survived the Great Depression and continue to represent the heart of American motorcycling. Robots handle tasks requiring extreme precision, such as welding and painting, while technicians perform many assembly and quality control steps by hand. Right now, you are looking at the latest simulator used in the development of new Harley-Davidson models. This is where engineers test rotational torque, translation forces, lower and upper forces, and many other parameters. Engineers secure the frame, engine, or complete motorcycle to a vibration table or specialized fixture. Harley-Davidson uses dedicated test facilities, including its product development center in Wauwatosa, Wisconsin. Sensors such as accelerometers, strain gauges, and force sensors are attached to key areas: the frame, handlebars, engine mounts, suspension points, and other components. These are vibration simulation systems that reproduce the stresses a motorcycle experiences during real-world riding. The goal is not only to test whether parts can survive, but also to ensure that the bike feels right to the rider. These are rare production footage of one of the most unusual scooters in history. What you're seeing right now is the BMW C1 scooter being assembled. The C1 wasn't built like a typical motorcycle, it was engineered like a compact car body, not a scooter. Italian design house Bertone was responsible for shaping and industrializing the body, while the engine came from Austrian manufacturer Rotax. The BMW C1 was never a typical scooter project. It was a collaboration spread across Europe's automotive industry. BMW developed the overall concept, handled the engineering, and controlled final assembly standards. Final assembly took place at Bertone's facility in Grugliasco, near Turin, meaning that although the C1 is officially a BMW, it was physically built in Italy. Power came from Rotax-supplied engines rather than BMW itself, offered in two versions, a 125 cubic centimeters and a more powerful 176 cubic centimeters variant for the C1200. Even its packaging had to be specially designed. Because of its unusual shape and fixed roof structure, the C1 required a shrink-wrap style transport system, rather than standard motorcycle crating. But the engineering ambition came at a cost. High production complexity, reliance on a coach builder like Bertone, and limited economies of scale made the C1 expensive to produce. More importantly, it struggled to find its audience. Scooter and motorcycle riders were already willing to accept risk in exchange for freedom and simplicity, while car drivers had little interest in switching to a half-car compromise. In the end, the BMW C1 became one of the most fascinating dead ends in modern vehicle design, a machine that was ahead of its time, but perhaps aimed at a market that didn't fully exist. The intended target, urban commuters who wanted scooter convenience without wearing a helmet, simply turned out to be too small. One of the most common complaints was its weight and awkward handling, particularly at low speeds. Compared to conventional scooters, riders often described it as bulky and cumbersome. The top-heavy design, limited practicality for everyday use, and relatively slow acceleration, especially in the 125 cubic centimeters version, were frequent drawbacks. In the end, the C1 earned a very divided reputation. A brilliant engineering experiment, admired for its innovation, but rarely loved as a practical daily rider. Here on the production line, you can see how the C1 was assembled using a flexible, automotive-style setup rather than a traditional scooter production line. BMW designed it around one bold idea, to make scooter commuting as safe as a car, so riders wouldn't need to wear a helmet. Final assembly was handled by Bertone in Grugliasco, Italy, adapting car manufacturing methods to a two-wheeled vehicle. Even the front wheel assembly was relatively straightforward and efficient, designed for fast installation within the production flow. Interestingly, a noticeable portion of the workforce on the line consisted of women, reflecting the highly manual, precision-based nature of the assembly process. At its peak, production involved hundreds of workers across the Bertone plant, although only a portion were directly assigned to the C1 line at any given time. And in the final moments of assembly, the BMW logo was simply snapped into place, the finishing touch on a very unconventional machine. The plant was best known for developing and producing vehicle bodies for major automakers, particularly within the Fiat group, as well as handling limited production and special series models. Instead, it was a traditional coach building and automotive assembly site, with a long history in car design and body manufacturing. This documentary takes you inside the manufacturing process of the BMW C Evolution, an electric maxi scooter developed by BMW Motorrad as the brand's first serious production electric two-wheeler and a direct precursor to the later CE4. Rather than a mass-market commuter, it was positioned firmly as a premium electric vehicle. Full production of the C Evolution ran from 2014 to 2021. Over that period, output remained relatively limited, averaging roughly 1,000 to 1,700 units per year depending on demand. At its core, the C Evolution was built around a lightweight aluminum structural housing paired with a liquid-cooled electric motor. Series production took place at BMW Motorrad's main factory in Berlin-Spandau, a site already responsible for building BMW motorcycles. Instead of a traditional chain, it used a belt final drive, and much of its engineering was based on BMW's existing motorcycle platforms. For this project, a dedicated 860 square meter assembly area was created specifically for the electric scooter program, seamlessly integrated into the existing production environment. Battery packs were assembled on-site in Berlin, using lithium-ion modules derived from the BMW i3 platform. Each scooter used 3 of these modules, with each module containing 12 individual cells. Because of the high-voltage nature of the system, all battery work was carried out in a dedicated, controlled production zone, separate from the main assembly line. From there, production continued with frame and chassis installation. The swing arm and electric motor were integrated as a single rear unit, combining the belt drive and planetary gearing system into one compact assembly. Right now, you're watching multiple scooters being assembled in parallel, a clear demonstration of how the C Evolution was built within a modern, highly flexible production system. The process concluded with final inspection, diagnostics, and dynamometer testing, a crucial stage in BMW's quality control system. It is used to fine-tune acceleration characteristics, throttle response, energy consumption, and regenerative braking behavior. It also helps verify top speed limits and ensures the battery and motor can withstand sustained thermal stress. Dynamometer testing allows engineers to evaluate performance in a fully controlled environment without relying on real-world riding conditions. Among BMW lineup, however, petrol-powered models like the C400X and C400 GT remain the brand's best-selling scooters overall. In addition, it plays an important role in homologation, confirming that each vehicle meets strict safety and regulatory requirements before it leaves production. Once complete, scooters were moved through the facility on elevated yellow carriers, designed to transport vehicles efficiently across the assembly hall while keeping them securely positioned during production flow. BMW core identity in motorcycling is built around its street, and touring motorcycles, especially models like the GS adventure bikes and large touring machines. These bikes form the backbone of BMW Motorrad global success, with strong sales volume, long-distance appeal, and a loyal rider base. In most markets, they are what people immediately associate with the BMW motorcycle brand. Scooters, on the other hand, have always been a niche within BMW's portfolio. Even relatively successful models like the C400X or earlier experiments like the C Evolution are produced in far smaller numbers and target a more urban, premium commuter audience.